The objective of U.S. Army research and development is to develop new weapons and equipment to support the individual American soldier. As never before in history, the future of your Army depends today on its research and development program. The battle of brains and pencils and blueprints, of imagination and innovation, is being waged in laboratories and industrial plants across the nation. The Army's research and development program covers many areas. There must be greater mobility on the ground and in the air. The need for increased firepower is being met with weapons that are smaller, lighter, and more potent. For command and control, better communications are required. The modern Army needs and must have improved logistical support that is more responsive and flexible to match fluid battlefields. With each technological advance, the importance of the individual soldier increases. Thus, the Army Research and Development Program is concerned primarily with this soldier. Research and development is constantly striving to give the American soldier every advantage in any future combat. Not only must this soldier be better trained, but he must be able to exist in the severe environment of nuclear or chemical attack. To show some accomplishments thus far, as well as new concepts being tested, here is a special progress report from the files of the Office of the Chief of Research and Development, Department of the Army. The new 5-ton lighter amphibious resupply cargo vehicle called LARC 5 embodies advanced designs, materials, and fabricating techniques that help it outperform similar amphibians. The vehicle has large diameter, low pressure tires, eliminating need for a wheel suspension system. Modern aluminum construction and welding has produced a leak-proof hull of great strength and buoyancy. The compartment housing the 270 horsepower engine permits easy accessibility for maintenance. 2 forward and 2 reverse speeds drive the wheels and the C propeller. The same steering gear turns the rudder and the wheels. The oversized tires are deeply recessed in the hull for streamlining. Speed on smooth water is 10 miles an hour. Turning radius is 35 feet. The LARC 5 matches or outperforms other vehicles in cross-country trials that include mud, sand, and other terrain. Ground clearance of the vehicle is 23 inches. 4-wheel hydraulic crab steering increases maneuverability. Over a hard surface, LARC 5 has a top speed of 35 miles per hour. Its performance in heavy surf is superior. It negotiates incoming and following breakers exceeding 10 feet in height. The sealed aluminum construction gives the hull non-swappable characteristics, and its smooth marine design provides good handling. In addition to the LARC 5, a 15-ton version of similar design is being developed and undergoing tests. When the LARCs join the already operational 60-ton bark, the Army will have a family of modern amphibians that will provide over-the-beach supply with greater speed and flexibility than ever before. The Navy ship Comet represents a new concept of ocean transport. It is designed to carry wheeled or tracked cargo. The cargo is driven aboard under its own power from the pier through side ports or stern ramps, thereby saving considerable time over conventional loading methods. To take full advantage of Comet's ocean transport efficiency, it was necessary to develop a new beach discharge lighter to land heavy wheeled cargo on undeveloped beaches. The prototype of this unique class of lighter, developed by the Transportation Corps, is the Lieutenant Colonel John U.D. Page. This vessel is designed to accept vehicular type cargo from Comet-class vessels and ferry it to shallow beaches, formerly accessible only to small craft. The purpose of this test was to learn the feasibility of stern-to-stern marriage of the Comet and Page for cargo transfer. An important requirement for successful marriage of the vessels is precise maneuvering. A unique propulsion system with two vertical axis propellers provides a more powerful and efficient thrust than that of conventional units. The variable pitch of the propellers gives the vessel its advanced maneuverability. The vertical axis propellers also take the place of conventional rudders. Blades can be removed individually if necessary to expedite maintenance. Another problem is to maintain close contact between the vessels and yet permit sliding. It is done by fastening the mooring lines to remotely controlled rams on the afterdeck of the Page. They keep the lines at a predetermined tension during transfer operations. After lash-up of the two vessels, the Comet's stern ramp is lowered to the deck of the Page. Sections in the tip of the ramp adjust to movement of the Page's deck. To support beach operations today, vehicles and materials must be moved ashore faster than ever. In this test, a variety of rolling equipment was used to show that this new concept meets modern transfer rate requirements from ship to shore. The Page has space for 600 tons of vehicles or general cargo on its nearly 18,000 square feet of open deck. When loaded, the Page moves from the Comet and proceeds to the beach to discharge through its bow ramp. The beach discharge lighter will add new flexibility and speed to the Army's over-the-beach operations. In his constant quest for peace, man has relied heavily on solid barricades for defense. When natural barriers became inadequate, he began building his own. However, as weapons became more sophisticated, defense became increasingly difficult. The need for defense mobility was not appreciated until the inflexible Maginot Line of World War II proved completely ineffectual. In defending larger land masses than ever before, the Army of today must also keep watch on the air above to meet an enemy who may attack from any quarter. To carry out this mission, mobility, ruggedness, and the ability to deploy on a moment's notice are vital. It demands an entirely new philosophy of defense, a vest pocket tactical air defense system. This system has an operations central and several coder-decoder groups dispersed over a large area along with adjacent missile batteries. Operations Central is the nerve center where data on hostile aircraft is transmitted electronically to a selected coder-decoder unit. This unit flashes target data to its missile battery. In event of enemy attack, personnel at Operations Central monitor the displays supplied by a network of their own and other search radars. Quickly, they select the battery in best position to block the attack. Information is electronically relayed in coded form to the selected coder-decoder group unit at the battery site. Battle orders are then transmitted to the fire unit and are executed at the precise time to ensure a hit. America's defensive weapons system must be built on a foundation of far-ranging electronic detection, instantaneous communication, unerring accuracy, complete mobility, and lightning-fast retaliation. The U.S. Army now has such a system. This is the new 51-ton M60 tank undergoing tests at Aberdeen Proving Ground. Its gun ammo system is designed to defeat all tanks of a potential enemy. Armed with a 105mm gun, it also mounts 50 caliber and 7.62mm machine guns. The M60 has a great many improvements over its predecessor, the Patton M48A2. One of the most important changes is a shift to diesel power, which makes an auxiliary engine unnecessary and gives the tank a far greater cruising range. The 6-inch washboard course proved the stability and durability of the M60's improved suspension system. Several aluminum components, such as the road wheels, have helped reduce overall weight of the tank. Ground clearance is 18 inches, 3 inches greater than Patton's. M60 successfully negotiated the standard 36-inch vertical wall without difficulty. A crew of 4 is required: tank commander, driver, gunner, and loader. Maximum speed is over 30 miles per hour on level ground. M60 will negotiate a 10% grade at a speed of 12 miles per hour. In this test of optimum gear performance, no trouble was experienced with this 40% slope. The trench crossing test determines whether the tank has sufficient angle of approach and departure, or any projections which might interfere with its mobility. The M60's performance in this facet of testing was excellent. M60 passed through the fording basin at a depth of 42 inches. The tank will ford to a maximum depth of 48 inches. In current testing, the accuracy of its firepower and amount of increased cruising range has exceeded expectations. Now in production, the greatly improved M60 tank is a significant contribution to the Army's effectiveness through better armored firepower. The M113 is Ordnance Corps' latest development in armored personnel carriers. Capable of transporting a driver and 12 men, it provides aluminum armor protection from atomic blast and heat, as well as from small arms and shell fragments. The aluminum used throughout the carrier saves almost 2,000 pounds of combat weight and makes it air transportable. It can travel at speeds up to 38 miles per hour and is faster than the present operational carrier. The highly mobile M113 can swim over inland waterways and is powered by a fuel-injected, air-cooled, supercharged engine. A snorkel-type air intake and exhaust provides smooth sailing. In addition to other improvements, the carrier weighs only half as much as its predecessor. Its silhouette is almost 2 feet lower. A bottom-hinged rear door provides quick exit for personnel. The M113 is now under production for issue to Army units. The Medical Corps' unique intestinal biopsy capsule makes it possible to obtain specimens of the lining of the stomach or intestines without anesthesia or surgical operation. The capsule contains a spring-loaded rotary knife, triggered by suction. A forceps is used to cock the knife, which is held in the cocked position by a key and slot mechanism. A slight pressure releases the knife, which neatly cuts the specimen with no pain after it has first been sucked inside the port. In practice, a standard syringe is used to suck in the specimen, and then to release the knife, as demonstrated with this piece of latex, which makes the capsule airtight. The capsule is small enough to swallow fairly easily. A tube is used to provide air pressure and to retrieve the capsule. This animated X-ray shows how capsules pass through the system. The specimen-taking operation, called biopsy, can be performed at any level of the stomach or intestine. Previously, this was complicated, for specimens deteriorated rapidly, since intestinal samples tend to digest themselves when removed. Furthermore, pain, tension, or anesthesia greatly alter normal digestive functions. The capsule allows the patient to go about his normal business and the doctor to take specimens at any desired moment. Several capsules may be swallowed at the same time or in series at the same level. This X-ray shows how the positions of the 3 capsules can be closely determined at the time specimens are taken. Once obtained, the specimen trapped inside the capsule is recovered by pulling up the tube and opening the capsule. It can then be quickly analyzed before it deteriorates. Because capsule specimens are fresh and intact and can be studied during the digestive process, this method is considered a great advance that will open up new frontiers of medical knowledge. This is the Corps of Engineers' revolutionary new all-purpose earth mover. It is light enough to be air-dropped, yet sturdy enough to do the work of machines twice as heavy. It is powered by a 250 horsepower air-cooled gasoline engine located in the rear. Because of its functional design, the machine serves as bulldozer, scraper, grader, cargo carrier, or prime mover. On turns, the dozer blade and push beams act as a unique steering mechanism, which permits the wheels to follow in the path cut by the dozer. High-pressure hydraulics are used to conserve weight. The 8-ton tractor can be transported by helicopter when front, center, and rear operational components are handled as separate loads. Another important feature is the way ballast is produced. Dirt is self-loaded into the scraper to ballast the lightweight machine to 32,000 pounds. A feature to be exploited during future research is the use of different body configurations between the front and rear sections. Such configurations as shop units and earth augers are being considered. A full tracked version of the tractor is also being developed for evaluation. The earth mover's flexibility of design is due largely to the use of an electrical system front-wheel drive and a mechanical system rear-wheel drive. The all-purpose tractor's greater interchangeability of parts and components should drastically reduce maintenance problems and expedite Army construction missions. This is the new 175mm gun on its highly mobile self-propelled carriage. The carriage can also mount the 8-inch howitzer and the 155mm gun, and will bring to the battlefield the mobility and flexibility that future tactics will require. After emplacing its spade and locking the suspension, the weapon system is ready for action. An automatic loader lifts the shells into position at the breech. The innovation of locking the suspension permits considerable reduction of overall weight and allows the gun to be fired from a platform less massive than previously necessary. With increments loaded, the automatic loader is moved away from the recoil. Spade and hydraulic shock absorbers, the T-235 is remarkably stable. Reduced dimensions and considerable reduction of weight enable the weapon system to be air transported in Phase 3 of airborne operations. Having rapidly occupied its position, the T-235 can be just as quickly march ordered and displaced to another firing site. The new GOER, a cross-country vehicle, gives promise of true off-road mobility for transport of heavy cargo in combat areas and has an inherent swimming capability. With a two-wheel prime mover and large diameter tires, the GOER concept is a radical departure suggested by earth-moving vehicles in the construction industry. Two prototypes of the GOER, a tanker and a cargo truck, were built under the auspices of the Ordnance Tank Automotive Command. The large diameter, low-pressure tires of the GOER can roll over higher obstructions with less resistance than that offered by tires of smaller diameters. Stability on side hill operations was another important aspect of evaluation. GOER should be more economical to operate than tracked vehicles of similar capacity. Thus, the burden on combat logistics should be eased by the new concept. Gears are shifted by means of a push-button type gear predictor system. This so-called wagon steer characteristic allows the two-wheel cab to turn up to 90 degrees in either direction, permitting greater maneuverability with a simple, rugged, and reliable design. In deep mud tests, this loaded 6x6 M54 cargo truck quickly bogged down, its undercarriage held fast. The GOER tanker, carrying 2 tons more than the truck, kept moving through the same mud, partly because of its lower ground pressure, primarily because of its high ground clearance assisted by the wagon steer. With a 30-inch ground clearance, twice that of the 6x6, the GOER passes over the mud that held the truck fast. Ground clearance may be further increased on future models. The GOER's structural strength, like that of planes, tanks, and turtles, is in its outer skin. This enables the GOER to swim on water. Waterproof parts and submersible engines are unnecessary. The treads of the large tires act like paddle wheels to propel the GOER at 3.3 knots in calm water. Simplicity of construction, increased mobility, increased payload. All these advantages, plus the adaptability of commercial GOER-type vehicles to military use, indicate the GOER design will be a major improvement over that of conventional Army vehicles. The Grumman MOHAWK is expected to increase the Army's capability for round-the-clock battlefield surveillance and target acquisition by electronic, visual, and photographic means. Flaps, wing slats, and drag brakes slow the MOHAWK to a stalling speed of 55 knots for landing on short, unimproved landing strips. It will be the first all-weather fixed-wing, short takeoff and landing aircraft delivered to the Army, which will provide a specific surveillance capability. Engineering flight tests have proven MOHAWK's ability to operate from a strip 800 feet long over a theoretical obstruction 50 feet high. Infrared observation and strip mapping equipment or side-looking airborne radar can be mounted with provision for a high-speed reconnaissance camera. MOHAWK can carry 1,000 pounds of observation and surveillance equipment in addition to the pilot and observer. The high-visibility cockpit design allows maximum visual observation. Side-by-side seating permits better communication between pilot and observer, with faster reaction to target sightings on either side. Low-altitude ejection seats and twin engines provide extra safety and reliability. The MOHAWK is ideally suited to its mission of low-altitude observation during shallow penetrations into hostile territory. Its powerful turbojet engines give it a cruising speed of 200 knots, a maximum speed of 275 knots, and a high rate of climb, making it less vulnerable than slower aircraft. The triple tail assembly gives better control at low speeds. MOHAWK has fulfilled service tests for rough terrain, short takeoffs and landings. It will be expected to operate from unimproved fields. A limited number of prototypes are currently being evaluated. Well on the way to being operational, MOHAWK will soon be available down to division level. new family of light, dependable combat radios for the soldier of the future has been developed by Signal Corps engineers. Smallest in the series is the revolutionary helmet radio, which provides dependable short-range communications between squad members for special, closely coordinated maneuvers. Another version under development, the versatile belt radio, uses the same compact circuit as the helmet radio. A new pack set, designed for the infantryman, has twice the capability of its predecessor. For extended range, from 3 to 5 miles, the new backpack radio is to replace an earlier model 2 times its size. All these sets can maintain reliable communications with each other and with the new multipurpose vehicular radio. This set does the work of 6 earlier radios, each twice its size. In the new family of combat radios, Army aviation has not been overlooked. A new aircraft radio with a range of more than 25 miles has been developed. All of these new field radios feature the latest circuit techniques and are designed for the utmost in easy maintenance. The Chemical Corps is testing psychochemical agents that temporarily change human behavior patterns. A study was made of the effect of one of these on a cat, which, prior to receiving a dose of the agent, reacted normally when confined with a mouse. When exposed to an extremely small amount of the agent, the cat's personality completely changed. Tests now in progress indicate that such agents have significant military potential. Your Army's research and development program is a continuing effort to help ensure the survival of this nation. Army industry teamwork is essential to the accomplishment of the Army research and development mission. To maintain superiority in our military arsenal, new ideas are essential. New weapons must be developed and perfected to meet new requirements. In these days of explosive advances in science and technology, Army research and development plays a major role in maintaining America's military supremacy.